Innovation Lecture Series, a distinguished platform dedicated to honoring the legacy of Dr. Bansi Dhar, a pioneer whose contributions continue to inspire innovation and excellence. This series is designed to convey thought leaders, trailblazers, and visionaries who share insights that shape the future, fostering knowledge, progress, and societal impact. We are delighted to have you all to join us for this inspiring journey today. At the heart of this initiative is the unwavering support and leadership of Vice Chairman Mr. Alok B. Shriram, whose dedication to research, innovation, and industrial growth has made the lecture series possible. It is my honor to introduce Mr. Alok B. Shriram, Vice Chairman, Shriram Institute for Industrial Research, Gurugram, Senior Managing Director and CEO of DCM Shriram Industries Limited, a multi-product conglomerate. With over 43 years of leadership experience, Mr. Shriram has played a pivotal role in industrial growth and policy advocacy, having served as former president of PhD Chamber of Commerce and Industry and president of All India Organization of Employers. His active contributions to industry and trade associations have been instrumental in shaping the landscape of innovation and enterprise. Sir, we are truly honored to have you with us today. May I now invite you, sir, to introduce the Shriram Institute for Industrial Research, Gurugram, and Dr. Bansi Dhar Science, Technology, and Innovation Lecture Series. Please.
Thank you. Good morning, Professor Pillai, esteemed guests, colleagues, and friends. It's a pleasure to welcome you all today to this important gathering where we celebrate the spirit of research, innovation, and the pursuit of knowledge. Let me begin by introducing you to the Shriram Institute for Industrial Research located in Gurugram, an institution that has been at the forefront of advancing science and technology for over 70 years. Founded by the visionary Sir Shriram in 1947, the Shriram Institute was established with a clear mission to drive industrial progress through the assimilation, application, and innovation of modern technologies. As an independent non-profit institution, the Institute has consistently delivered groundbreaking work across multiple disciplines, including green energy, environmental sciences, waste and wastewater management, and infrastructure. Today, Shriram Institute for Industrial Research remains a hub of cutting-edge research with its specialized laboratories in nanomaterials, environmental engineering, clean energy, and infrastructure and new materials. The Institute is involved in projects ranging from developing high-performance materials for environmental monitoring to advanced hydrogen production and fuel cell technology. With a dedicated central instrumentation facility, the Institute supports a diverse range of research initiatives aimed at solving some of the most pressing challenges of our times, from sustainable energy to environmental protection. The work being done here exemplifies the Institute's legacy of technical problem solving and knowledge transfer, leading to real-world solutions that benefit both industry and society. And now it is my distinct privilege to introduce the Dr. Bansi Dhar Science, Technology, and Innovation Lecture Series, which is an integral part of our effort to foster interdisciplinary dialogue and inspire the next generation of thinkers and innovators. This series, instituted in memory of Dr. Bansi Dhar, the long-time Vice Chairman of the Shriram Institute, aims to address critical areas of public health, education reforms, sustainability, and innovation in India. The lecture series serves as a platform for distinguished speakers to share their insights on various topics. For example, past lectures have tackled urgent issues like infectious disease management during COVID-19 pandemic, the importance of liberal education for innovation, the need for robust science and technology ecosystem to drive sustainable growth in India. These discussions are a tribute to Dr. Dhar's vision which was grounded in a commitment to advancing science and technology for the greater good of society. Dr. Bansi Dhar, who passed away in 2004, was a passionate advocate for scientific research and industrial development. His leadership helped shape the institute during a pivotal time, and his legacy continues to inspire all of us who are a part of this institution today. Let me take this opportunity to share an important piece of information. The Shriram Institute for Industrial Research, Gurugram, is in the process of shortly transitioning into the Dr. Bansi Dhar Institute. A formal announcement to this effect will be made, wherein the Gurugram campus will be transferred into the Dr. Bansi Dhar Institute to give focus to its research. In conclusion, as we continue to honor his memory, the Dr. Bansi Dhar lecture series reminds us of the vital role that research, education, and innovation play in shaping the future. Through these lectures, we hope to bridge the gap between scientific discoveries and their practical applications, ensuring that science remains a force for positive change in India and beyond. Thank you for being here, and I look forward to hearing our esteemed speaker today. Thank you.
Thank you, sir, for your insightful words and for setting the stage for today's session. Now, it is my privilege to introduce Dr. Becky M. Thomas, Director, Shriram Institute for Industrial Research, Gurugram, who will now introduce today's distinguished speaker. Dr. Thomas is a renowned immunologist and scientist with over 25 years of expertise in life sciences, including 15 years dedicated to pioneering drug discovery and biotechnology advancements. Her contributions to multidisciplinary research, antiviral therapies, and vaccine development have been instrumental in shaping the future of healthcare and innovation. Dr. Thomas, may I please request you to introduce our esteemed speaker for today's lecture.
Thank you, Krati, and a warm good morning to one and all. It is indeed my honor and privilege to introduce our speaker, Professor V.N. Rajasekharan Pillai, who has been a role model and a mentor for me. Professor V.N. Rajasekharan Pillai is a distinguished academic leader, scientist, and a policymaker who has played a pivotal role in shaping India's higher education and research landscape for over 5 decades. Currently, Professor Pillai is the Vice-Chancellor of the Somaiya Vidyavihar University, Mumbai. He has previously held prestigious leadership positions, including Chairman and Vice Chairman of the University Grants Commission, Executive Director of NAAC, and Vice-Chancellor of multiple universities, including Indira Gandhi National Open University, Mahatma Gandhi University, and Cochin University of Science and Technology. His contributions span across education, policy, accreditation, open and distance learning, and scientific research governance. Beyond national leadership, Professor Pillai has been a key figure in international education policy, having served on the UNESCO's Global Policy Drafting Committee for Higher Education. His expertise has influenced the transformation of national institutes of technology into university-level institutions, accreditation of universities, and elevation of premier institutions to the deemed to be university status. He continues to guide higher education development as the Chancellor of ICFAI University, Tripura, and a visiting research professor at the University of Lausanne, Switzerland. A recipient of numerous national and international awards, Professor Pillai has been honored with multiple Lifetime Achievement Awards from the Royal Society of Chemistry, Indian Chemical Society, and the Indian Science Congress Association. He has also received the Presidential Gold Medal from the former Prime Minister, Dr. Manmohan Singh. Professor Pillai is also the recipient of the M.V. Pillai National Award for Academics. His exceptional contributions have left an indelible mark on India's education and research ecosystem. Through his leadership, scholarly achievements, and visionary approach, he continues to shape the future generations of academics, scientists, and innovators. Before I invite Professor Pillai to deliver the talk, a few pointers. Please keep your cell phones on mute or silent mode. Participants, kindly do not unmute yourself during the talk. Request you to post your questions in the chat box, and we will address them after the talk has been delivered. Welcome, Professor Pillai, and request you to deliver the 8th lecture under the Dr. Bansi Dhar Science, Technology, and Innovation lecture series. Over to you, sir.
Thank you. Thank you for the wonderful introduction, Dr. Becky. Distinguished Chairman and Vice Chairman, SRIFIR Institute and the Dr. Bansi Technology Foundation. To be here delivering the lecture. Dr. Bansi Dhar who was president of the SRIFIR. I am also glad that I am speaking on a topic which to the activities Bansi Dhar has been doing. I had for 15 years, I had occasion to visit SRIFIR Institute, or maybe one or two occasions, and the activities of this significant way. Institute has contributed significantly to knowledge and in various disciplines like V.N.R. and Environmental Science, water and wastewater management, and education as a whole. That the education is for enhanced life management systems. They were looking at intervening or providing knowledge in this area. Dr. Bansi Dhar was a visionary in science and technology for the greater good of the society, and privileged to give a lecture in technology innovation lecture series named after Dr. The topic I have selected today is about science, technology, education. I am basically a scientist. I am actively involved in developing and building new science institutions in the country, advisory capacities as well as an actor. I see that a good number come in science education in this country, whether it be the IITs, NIT, science education research which have started during Dr. Manmohan's Indian Institute of Science Education and Research. And so we also see that our science from all these institutions and premier universities working all over the world, their knowledge and skills for very specific purposes. They are contributing to innovation at all levels. To a review of science, advanced science in this country, I interact with, I see that they have also some sort of a, that the education which they, technology, engineering, in all, they are limited to some extent, in the sense that when they go out of the institutions, they are not really finding applications of what they are learning. There is also declining taking science in all our colleges and universities. It's an alarming fact. And the national education policy has come, and it looks at education as a whole. National education policy integrating all types of subjects which are relevant, which are text of the major core subjects, and we are all working on it. Almost every year in the name of national education policy, and then lot of good things. Look at the one problem. Look at national education policy, and then education imperatives in this country. Only by creating some sort of an opportunity for infusing creativity and innovation in engineering and mathematics, we can look at improving science education. So, which I'm going to deliver is STEM. That is, STEAMing means science, arts and management. That is STEAM. And then STEM is science, technology, engineering, mathematics. So during the last 25 years, STEM education was very STEM education. It has come opportunities for in the education sector as well as in the skill sector. And how, but when it comes to arts, it is not just subjects only. Creative thinking, design thinking, fine arts, all these things come under the STEM education can be ultimately by doing this. And we have seen many of our institutions, they just the technology institutions, they are bringing humanities and social. Major IITs, old IITs, they had, but they were all standing as separate. Definitely provide education in those areas, but how take the arts into science, technology, engineering, and mathematics education. That is a challenge. So that all art subjects which they provide opportunities for different unique pedagogical approaches in it. Visualization, storytelling, or hands-on projects, project-based learning, all these things are. So from right from school education to higher education, there has been a systematic attempt to provide integrate arts subjects all domain of science, technology, and engineering and mathematics. Points, right? So, the so-called STEAM education, technology, engineering, arts, and mathematics. It's not it's development. Maybe for the last 20, 25 years about this, some of the institutions have been doing it. Some departments are doing it. Implementation things are not that that way in our country. So education lies in the science, technology, engineering, and mathematics, and this shift from STEM to reflects a growing recognition of the importance of arts in the fostering of innovation and thinking. Trace the history of STEM education. It's a very from STEM education. How we see the modern teaching approaches. So the foundations of can be traced back to the mid-20th century. The launch of the Soviet satellite Sputnik 57 prompted a surge in the internet technology in the United States. During this, education systems worldwide became greater emphasis on science, technology, and mathematics. This was driven by students for careers in these fields, particularly in the West, in STEM education to maintain global competition in the Cold War era. To several interdisciplinary courses, cross-curricular collaborations, designing lessons, and exploring geometric technological innovations. These are all Renaissance interventions. And 2000s, STEM became a formalized concept. In growing demand for skilled work and engineering fields, education policy may be advocating for a curriculum that technology, engineering, and mathematics. The equip students with the technical skills evolving global economy. Science, technology, engineering, and mathematics education which are designed to promote analytical thinking and collaboration, deemed essential in a technologically. The so-called limitations of criticism for neglecting the arts and creativity, which innovation and holistic education. That focusing solely on technical ability to think creatively and approach problems from multiple perspectives. This is the real fact also. When outcome of the university education, this is particularly in our university systems, a real fact. So this can be bridge of introduction of a more comprehensive education model. That was the story. That was the genesis for the genesis of the STEAM. Integrating arts industry. STEM to STEAM began in the late 20s. The educators have recognized the need to incorporate arts into the model, resulting in a more interdisciplinary approach. The addition of arts A represented the arts encompassing discipline, visual arts, music. This new focus on the innovation by encouraging students to apply creativity and design thinking to technical challenge. The STEM movement getting transformed was championed by individuals like a designer and a technologist, the importance of art and design and technological innovation. Spread the idea that creativity with technical expertise could lead to ground and solutions. After 2010, STEAM education popularity, particularly in the Western countries, began incorporating project-based learning that scientific artistic expression. For example, might design and build a bridge, engineering combining together, while also considering the functionality of the structure, arts and design, contribution of arts and design. approach helps students see between subjects and apply their knowledge in scenarios. STEAM also gained support from organizations in school design, which played a key role for the integration of arts in the STEM fields. This initiative emphasized the importance of nurturing technical capabilities in students, preparing them for a rapidly. When we just look at the key of STEAM education and the examples, we can see problem solving is the first and foremost. One of this creative problem solving into the learning process. By combining technical knowledge with artistic creativity, students learn to think outside the box and develop complex problems. STEAM education places a strong project-based learning, already highlighted. Are encouraged to engage in experiments, creative that allow them to apply theoretical concepts and practice. And then interdisciplinary culture is getting practice through STEAM education. Collaboration in bringing together knowledge from diverse fields approach encourages students to see the seemingly unrelated subjects, having a more holistic understanding of the world. The inclusion of education has also helped foster a new generation by integrating creative expertise. STEAM equips students to think critically, communicate effectively, and approach problems from multiple views. So this gives a paradigm shift in pedagogical approaches even. Then this is very important. In today's market, employers increasingly candidates with both technical skills and abilities. Education properly implemented addresses preparing students to be adaptable, innovative, and able to collaborate across disciplines. These traits that are highly valued, ranging from engineering to the creative arts. While traditional STEM education appealed to students with strong mathematics, the inclusion of arts in this broadened its appeal. Students have been intimidated by STEM subjects. That's the point which I mentioned in the introduction itself. More engaged when creative elements. This inclusivity makes STEAM more accessible to a wide range of learners with diverse talents and interests. The evolution of STEAM education from the model represents a significant shift in how we approach learning and innovation. Recognizing the value of creativity and integration in science, technology, and mathematics, STEAM prepares students for challenges and opportunities for the future. As the world continues to evolve, the STEM education and its will remain essential in fostering the innovators, thinkers, and problem solvers. And the practical guides STEAM education, CRT, our school education and capacity building institution, they are also all these possibilities. And we have got STEAM education as increased to the development of 21st century learners and 21st century the stock. These are the skills needed to rapidly changing world. They go traditional academic knowledge and focus. In science subjects, any subject, usually in classroom we provide only knowledge and our lectures, practicals, project work, all this. Knowledge and skills are for enhancement of life of the society. And if you want knowledge and skills to the society, they should understand the conduct skills. And definitely, this arts education, these subjects, all these subjects to arts, humanities, creativity, all these gives a better understanding of the knowledge and skills. And this text-context relation is nothing but the social relevance of it. Therefore, the social relevance of science, technology, mathematics education is or effectively supplemented, necessarily integrating arts education, analyzing information, evaluating, finding creative solutions, generating, thinking outside the box, change, finding, evaluating, and using information, adjusting to changing circumstances and skills. These are all necessary of the STEAM education. STEAM integrates the arts with creative. Students are encouraged to experiment, think outside the box. Education promotes innovative STEAM project. I mentioned about the project-based learning and complex challenges that require students to analyze, evaluate options, and develop solutions. Method and engineering is critical thinking skills. And interpretation enhance critical communication and collaboration are essential ingredients in education. Presenting projects, and engaging in discussions, communication skills. Performing integrated into STEAM, great enhance those skills. STEAM often incorporates technology, robotics, and digital design. To use technology as a tool for creativity, problem communication. Digital art.
Yes, sir, we can hear you now.
Some connectivity problem.
Yeah, there was a bit of a connectivity problem, but we can hear you now. So please continue.
Yeah. So I thought I will use some time for this is interesting. I will just leave it up. I will say along with all these recommendations.
Yeah, so you can continue.
No, I can hear you.
Please go ahead. We can hear you.
Can you? No, but there is. Can you hear?
We can hear you, sir.
Okay. So I'm concluding.
Okay.
I'm concluding in the sense that the STEAM education a rich and engaging learning environment. Students to develop essential skills thrive in the 21st century. By integrating system, we create a more holistic and relevant experience that prepares students for such changing world. I will send you the whole text of the lecture for the maybe for circulation. Thank you. Thank you very much.
Thank you, sir, for your enlightening
Thank
lecture.
you. Now I am back. Actually. So if there are questions.
Thank you, sir, for your enlightening lecture and for sharing your valuable insights. We now move into the interactive segment of our session, the Q&A round. And I will be moderating this discussion and presenting some of the most engaging questions from our audience. So let's begin with the first question. In a world full of competitive examinations, can skill-based education policy be implemented effectively? What challenges would we face?
Hello, can you hear me?
Yeah, yes, sir.
So I got the question.
Okay.
Is the most important. Examination is not to the student. It is to find out what what we have taught is done by the students. Examinations really are some sort of a they are creating some sort of negative impact on acquiring education. I also know schools and even though they are they may not be a system or the conventional system of education. There are schools in which up to there are no examinations. They are doing excellently well. So definitely the competitive examination, competitive examination purpose. For example, getting into a particular institution. This has to be probably we have serious thinking, rethinking on it to curb this competitive spirit. Probably in the competitive examinations we can. It is not just the 0.001% is more important. Probably the skills in STEAM education. When education, even the examination thing has to be and the level of the mode of assessment has to be different. When you, for example, when you assess mathematics, when you assess physics, there is a pattern. But when it comes to design thinking, arts appreciation, these levels of will not work, and there are probably we have how art is taught, how dance is taught, how they examine. This is the real thing, and therefore, the conventional examinations, STEAM practices that may not serve the.
Okay, so moving towards our next question. A more interdisciplinary approach in STEM education integrating ethics, arts, and humanities. How can educators ensure that not only develop a technical expertise, but also the critical thinking and ethical reasoning needed for real-world problem solving? Additionally, how can incubators and innovation hubs collaborate with educational institutions to reinforce this holistic learning in a way that drives tangible impact?
You know that in selected institutions in several institutions, there is project-based learning. Students are supposed to learning is subject from the good institutions. They should civil society organizations. Students should spend time with the organization, and definitely they should work the nuances of the industry also. That's very important. The new approaches are that, of course, the students need to go experiential learning and learning outside the education for a specific for a skill. And even in the conventional national education policy, 40% of the credits can be earned from out, and 40% of the credits can, for example, that assessment and certification of. There's a lot of knowledge and skills acquired by the ordinary people. It may be in painting, it may be in agriculture, in conventional traditional medicine like Ayurveda. There are a lot of education happening. For now, when I was studying the Indira Gandhi, was introduced a system known as assessment and right. If you just look at the total knowledge and skill in the world, you can see that is provide only part of knowledge. The rest of the knowledge and skills we have all people who work in the area. They may not have a degree. That is called prior learning. So there system by which the prior learning has to be integrated into education. Now, of course, the has come forward with the
So our next question is, how can we successfully implement STEAM in an organization?
Hello.
Yes.
Can you hear me?
Yes, sir. Yes.
Okay.
So I'm repeating the question.
So experience project-based learning, the education institutions. These are all possibilities. Possibilities are there in higher education. 40%, up to 40% of the credits can by spending time society organizations and a number of acts. And there has to be a system by which such the institutions which I preside over now, institutions try to get this other institute, working with the society. The real applications of knowledge with the society at all levels. Definitely, it can they can understand the new. Thank you.
Okay. So our next question is, should there be more of stimulator-based techniques which would assist students comprehend live real-time industry scenarios?
Can you repeat the question?
Yeah. Should there be more simulator-based techniques which would assist students comprehend real-time industry scenarios?
You are asking about industry?
Yes, sir.
No. I'm asking how industry. Hello?
Question.
Yeah. Should there be more simulator-based techniques which would assist students comprehend real-time industry scenarios?
Yeah, I think that should be a possibility. You know that now that is one possibility. Many of the Indians and many from civil society, they can spend time with education institutions. It's not enough. I think we should ask that education institution also should spend at least in civil society 1 month in civil society organizations and industries. So only then we understand the real application and it will become more popular. Now it's happening, but the success stories of such need to be popularized and other institutions also. And that solution which I suggest for.
So the next question is, will adding humanities in STEM not lead to dilution of STEM circling?
Hello?
Yeah, sir, I'm repeating the question.
Yeah.
Will adding humanities in STEM will not lead to dilution of STEM curriculum?
No, it will lead to any dilution that I don't. Probably we have to just be a overall scenario and apply it. Then there will not be any dilution. That's my.
Okay. So moving towards the next question, can we add some features to STEM into humanities?
Can we?
Add some features to STEM into humanities.
Surely, that of course they should also understand. Science and technology are important. It is definitely integration. When we say integration, number of students should also, for example, we had a honors course. The program History of Science and Scientific Development. That students should also understand the science and science development. Maybe understanding of core science be necessary, but they should understand of science and scientific development and technology. The arts students should definitely know it because they will be coming to policy making. Several it is possible, and therefore necessary. That's my point.
So moving towards the next question, what can be the key challenges that educators may face when incorporating humanities and ethics into science and technology curriculum? Can literature and storytelling or any other tools be used to achieve integration?
No, it is really one tool, but a very effective tool. I fully agree. Not many areas. Even the art history. Structure, spending time with musicians. These are all. We talk about sound engineering and all that. Sound, visual arts is very important. Spend time visual arts, maybe traditional arts and arts forms, music, theater, drama. All these things are very, very important. It's not only storytelling is only one of these things, but all these interventions like art appreciation, visual and performing arts, all these are getting integrated into education. When we say arts, it is more on such things for creative thinking and creative arts. It is not only storytelling, but there are several forms of arts.
Okay, so I think we have no more questions now. So thank you, Professor Pillai, for addressing these thought-provoking questions with such depth and clarity.
Okay. Thank you very much.
Thank you, sir. Now, as we approach the conclusion of today's enlightening session, it is my privilege to invite Dr. Sufia Khan, Deputy Director at Shriram Institute for Industrial Research, to deliver the vote of thanks. Dr. Khan is a distinguished researcher and an inspiring leader who has played a pivotal role in driving innovation, research excellence, and collaborative initiatives with our institution. Ma'am, may I please invite you to deliver the vote of thanks?
Good morning, everyone, and namaskar. It is my honor to propose the vote of thanks for today's enlightening session on the Dr. Bansi Dhar Science, Technology, and Innovation lecture series. First and foremost, sir, I would like to extend our heartfelt gratitude to our distinguished speaker, Professor Pillai, who is a well-known scientist, academician, and policymaker for his thought-provoking and inspiring talk. Sir, you have well said today that science needs arts, and I'm truly aligned with your ideology of this fact, because by incorporating the arts in the science will give the more sustainable and the innovative solutions, and the marriage between the arts and the science in the era of the AI and the ML is the high need of our art to save this earth and to provide the more sustainable and the innovative solutions. So thank you so much, and we are deeply grateful and thankful and privileged that you have accepted our invitation and took time out from your busy schedule to share your insights and ideology and the wisdom of words today with us. We are immensely thankful to Alok sir for his gracious presence. So you always been the motivation source and the guiding light to all of us. Thank you so much. And I'm extending my warm thanks to all the participants who have attended this lecture series on the online and the offline mode, and your engagements and your enthusiasm during the event has been truly instrumental in making this event a truly success. And my special thanks to our organizing committee members for their dedicated efforts for behind the scenes for ensuring the seamless execution of this event. We are also grateful for all our supporting staff and IT members for providing us all the logistic support without which this event would not be possible. So thank you so much for being as a part of this lecture series. And I'm very, very sorry during the whole conversation, there was some issues of the network issues, and sometimes that audience may not be able to listen properly. So I'm deeply apologize for this fact. So thank you once again for being the part of this great lecture series, and stay tuned for our next lecture series of the Bansi Dhar Science, Technology and Innovation, and wishing you all a wonderful day ahead. Thank you so much again.
Just my pleasure to be there. Definitely the institute, maybe when I visit Delhi, I will come out.
Yes, sir. Yes, sir. So you are welcome. So you are welcome. Yes.
With this, we officially conclude today's session and look forward to welcome you again at our next lecture. Have a wonderful day ahead. Thank you so much.
Thank you.